Unit 3. Beautiful. This is radical functions, really similar to Unit 2, except you start with a radical, and then we move on from there and do our mapping rule and stuff from that point. So, give or flip. We are doing long answer questions. Determine all the invariant points for the graph. You need to know that an invariant point for this happens when y equals 0 and when y equals 1. Y equals 0 just means I'm solving x squared minus 4x plus 3. This is a nice, beautiful factoring. Multiplies to give you positive 3, adds to give you negative 4. Look at that guy. You are not done here. Everyone ends here. It is asking for invariant points. These are not points. These are equations. The point is your solution that you get and the y component that I plugged in. This is gorgeous. Make sure you do that. Same thing for when y equals 1. 1 equals x squared minus 4x plus 3. We're moving our 1 over to the other side. This one is not as nice as the last because you need to use quadratic formula. I do not want to go through all of that right now. I believe you know how to do quadratic formula. If you need it on your test, it will be given to you. You do not need to memorize it. You get what for your solution when you do quadratic formula. When you do it, you get x equals 3.41 and x equals 0.59. Make sure you write it as a point, 3.41. Stop whining. And 1 and 0.59 and 1. Gorgeous. I'm not doing quadratic formula. I don't want to, but I believe in you. You can do it. Same thing. Radical functions. This is a mapping rule, just like what we did on the last one. Big thing. When I see this, I see a guy that's not factored, so we need to factor it out. Y equals root. Taking out my negative 1/3. When I do that, I multiply by the reciprocal. Changes to a negative 3. Gorgeous. I also would like to move that 4 over, so I add 4 to the end. That is not underneath the radical, it's just at the end of your equation. You can't see what I'm doing. Okay, better. List the transformations required. Nothing on the outside, no vertical stretch. There's also no reflection affecting your y value, which would be a reflection in the x-axis. On the inside, I do have a horizontal stretch of a factor of 3. Take the reciprocal. It is not negative because the negative represents a reflection in the y-axis. I have a minus 3, so it has a horizontal translation of 3 to the right. That could also be called a phase shift. We do that in sinusoidal. We call it a phase shift instead of a horizontal translation. Same thing. And this plus 4 means I have a vertical translation of 4 units up. Gorgeous. Mapping rule goes off this guy. X, y would be changing to your negative does go here. You do the reciprocal of your 1/3, x plus 3. There's nothing happening, no vertical stretch. And then I do a plus 4. From here, we can do our points really quickly. So you're given these guys. You need to know, this was really nice too, and it gave it for you. You should know your original function is 0, 0, 1, 1, 4, 2, 9, 3. Should know that. And I am plugging it into my mapping rule. So your new guy, I plug in my 0, I get positive 3. Plug in my 0, get positive 4. 3, positive 4. Here's your starting point. Same thing, I plug in 1, 1. Negative 3 plus 1 is 0. 1 plus 4 is 5. Gorgeous. Plug in my 4. Negative 3 times 4 is negative 12. Plus 3 is negative 9. 2 plus 4 is 6. Negative 9. I can't see this really good. 1, 2, 3, 4, 5, 6, 7, 8. Oh, negative 9 is out of the picture, but it would be up here-ish. If it's outside the picture, you don't have to draw it, but make sure you have a beautiful curvy graph. Okay. State the domain and range. Your domain, your x value, looks like it is less than. Oh, I put that in the right spot. That should have been 3. Sorry. 3. It's also equal to. Your range was y is bigger than or equal to 4. You could do it like this, negative infinity 3, and then 4, positive infinity. Most people I find like these guys. And sketch the graph on the grid, I already did. Great. This one I did in class. It's just looking at your invariant points and then drawing your curves. So your invariant point would be where it's equal to 0 and where it's equal to 1. And then you curve it out. I'm going to leave those for you. I'm also going to leave question 4 for you. Determine the domain and range of this. You would need to change this into a vertex form to find your minimum. Draw a really quick graph, and then do your domain and range. Same thing as what's here, but this graph is always given to you. Or already given to you, sorry. Question 5. These were nice. These showed up on all of our tests that we did. X-intercepts is just a factoring thing. So I'm taking out a negative a half. I'm going to do that up here. When I take out a negative a half and an x, I'm left behind with x minus 8. So your x-intercepts are 0, 0, and 8, 0. You should know that when I take the square root, they stay the same. Your y-intercept here is also 0, 0, because there's no constant term on the end. Taking the square root of the y term, this is a coincidence that it's the same. It is not always the same for a y-intercept. Usually you take the square root of the second term. Max value. Max or min, this kind of confused some of you guys. This is just saying what's the vertex or the y component of the vertex. So I have to do negative b over 2a to solve for the x component and then plug it in. If I do that, negative b over 2a, I am getting negative 4 over negative a half gives me, if you work the whole thing out, positive 8. Okay, so halfway between your x value would be 4, and when you plug it in, you get 8. They only want the y value for a max. If you give a vertex, I wouldn't say it's wrong. And then the same thing would be the square root, because it's a square root function. There's no min if there's a max, because it's quadratic. So beautiful. There is a minimum of the square root function, so you need to know the minimum's always 0. If you were given this, you would have a graph, or you could do a quick one on the side. Your domain for quadratic is always XCR. Your range is restricted by your y-intercepts. So if I drew a quick graph, I know my intercepts are at 0 and 8. We did it. I also know it opens down. Okay? So when I take the square root of this guy, your negative portions go away. You're only left with what's between in here, which is y at 0 is less than or x is less than 8. Pico, stop whining. Range, same thing, it opens down. So your range of your quadratic from grade 11, you would have done this, is y is less than or equal to your maximum. Now it's less than or equal to your maximum of root 8, but it's also slammed between that 0 because when you take the square root, it can't go below that. Invariant points I solve by making it equal to 0 and making it equal to 1. Do your original equation, it saves you a bit of a headache because that has a square root in it. When I do that, I have 0 equals negative a half x squared plus 4x. When you solved it, you get your x-intercepts, 0, 0, and 8, 0. I also have to solve it when it's equal to 1. Negative a half x squared plus 4x. This guy, they completed the square in the answer key. I would expect you guys to do the quadratic formula because you don't need to complete the square. When you work it out, you also get an ugly number, 4 plus or minus root 14. I believe in you guys. I know that you can do quadratic formula, so I'm not going to show you it. Okay, you will be given the quadratic formula if it shows up. Last one is a graphical thing. We've done graphing a million times, so like just that left-hand side we did. Just that right-hand side you did. Like you can do that. Graphically means you're looking at the intersection points. Would this be a long answer? No, it hasn't been a long answer for us. So my bets would be that it's not a long answer for you guys. A multiple choice would give you like one of the graphs and say solve for when it's equal to 3, and then you can do the intersection yourself if that was to show up. Okay, so I'm not going to do that one either. The most important ones were the ones I did. 1, 2, and 5. But the answer key for the rest are there if you're very, very interested, which you should be, because they could show up on the multiple choice. Okay, moving on. We got 2 units left.